Okay, we've got one last idea to talk about in this particular chapter because it's related to radicals or taking roots. It's called square root of negative numbers. Now, so far we've said square roots of negative numbers do not exist, but that was an almost lie. What we meant was that it's not existing in the set of numbers that we know about, right? It's, for example, for a certain period of time, people didn't know irrational numbers existed, right? They thought all numbers were rational. Similarly, um, we have something like that here. There's a moment when square root of negative numbers was defined by a mathematician Gauss. So the definition goes like this: the imaginary number, that's what these are called, imaginary numbers, I for imaginary, is defined as the solution to x squared equals negative 1, right? What that means is that x equals I and I squared equals negative 1. Now the name imaginary is imaginative, but the numbers are not any less real than real numbers. They actually model physical movements like rotation, as we're going to see later. Our definition is then that I squared is negative 1 or I is square root of negative 1. Analogously, it's like saying if x squared is 5, then x is square root of 5. So if I squared is negative 1, I is square root of negative 1. So now we are able to define square root of negative numbers. Like square root of negative 25 becomes square root of 25 times negative 1, which can be split as square root of 25 times square root of negative 1, which is 5i. And you can verify 5i times 5i is 5 times 5 times I. It's 25i squared is negative 25. Similarly with negative b, here are some examples. So that is square root of 9 times square root of negative 1, 3 times I. Square root of 3 times square root of negative 1, root 3i. Square root of 80 times square root of negative 1. Factor 80 here on the side, that's 2, 40, 2, 20. Scroll down to 10 to 5. So there are two pairs, which means that's 4 root 5 I. Similarly, 48 root negative 1, that is I. 48 is 16 times 3, so that's 4 root 3. That's root 11 root negative 1. So pretty straightforward, right? And I'll leave you to verify these to make sure that these are actually the square roots. The next definition is that of a complex number. Now, so the next question is to explore how these numbers or how the imaginary numbers interact with the numbers we are already familiar with, which are called the real numbers, which recall are written as R. So definition, a complex number is a number of the form a plus b times I, where a and b are real numbers. A is called the real part of the complex number and b is called the imaginary part of complex number. In general, we have this hierarchy. You have complex numbers, and then when you set b equals 0, you get all the real numbers, and when you set a equals 0, you get all the imaginary numbers. So this is a larger collection of numbers. Okay. Now, in fact, in general, for example, you can think of it as complex, right? And then in the complex, you have the real. Within the real, you have like rational, and you have irrational, and so on. So there's a bunch of classifications of numbers. Examples: negative 4 plus 6i, 0 plus 2i, 3 plus 0i, 2 minus I, 3 minus 2i, etc. Now, the neat thing about complex numbers is that we can visualize them. And it's something you've done before. If you let x be the real axis and y be the imaginary axis, then any complex number, negative 4 plus 6i, is actually the point negative 4 comma 6. 3 plus 0i is the point 3 comma 0. So if you plot it here, negative 2, negative 3, negative 4, 1, 2, 3, 4, 5, 6. This point is somewhere here. 3 and 0, that's here. So this point can be thought of as, this is 3, 0, right? This point is negative 4 plus 6i, which basically means it is negative 4 comma 6. And in fact, you can do a bunch of things. For example, you can connect it here and you can call this length. You can find the length and all, which we're not going to cover in this particular chapter, but it's going to be a part of an exploratory project. Once you've defined complex numbers, we're going to be looking at operations in the next video.